All right, guys, let's finish up this lesson. So I have angle AB at 8.4 degrees, side AB at 40.5. When we did this before, we said that C is our 90-degree angle. C is opposite. I always like putting A at the top, B on the side, so I have little a and little b. And I know that little a is 40.5. Right. So, we get our 90-degree angle for free. And then using our idea that all three of these add up to 180, or these two add up to 90, I get 81.6 degrees for side B, or angle B. All right, so when I do this, hopefully remember a little bit from geometry, when you have a triangle like this, the smallest angle is going to have the smallest side, and we know in a right triangle, the largest angle, 90 degrees, is going to have the largest side. So when I find B, it better be larger than 40.5. When I find C, it better be larger than B. All right, how you do these is up to you. So for me to find B, and I have A, I'm just going to use B because. No reason, just because. So in relation to angle B, side B is opposite, and I have adjacent. So I'm going to go the tangent of theta is opposite over adjacent. So the tangent of 81.6 degrees is B over 40.5. I'm going to go to some device, do my math. And I got a pretty good number. So side B is 274.265. And that looks significantly bigger. So I figure that's going to be about right. 274.265. All right, to get C, if I wanted to find C, I could do the cosine of angle A is 274.265 over C, where I know A is 8.4. There's multiple ways to do this. So I'm going to use Pythagorean theorem. C squared equals 40.5 squared plus that long decimal squared. Now I want you to use the whole thing. Don't use the rounded value. So I'm going to go to the calculator for Desmos. And then I'm going to take the square root of this long decimal. Get 277.240. All right, so once you find you're given one angle, you automatically know angle C is 90. Subtract that from the angle you're given from 90 to get the other one. And then use a trig function to find what you need. All right, now we're going to draw some pictures. The sun is 20 degrees above the horizon. Find the length of the shadow cast by a park statue that's 12 feet tall. It's very important. I always do this, is draw the picture that we're given. All right, so we have a park. Here's our grass. We have a statue. All right, there's our statue. It's a statue commemorating me. All right? Our sun is here. All right, so the sun is 20 degrees above the horizon, so I'm going to say This is my angle to the sun, which is 20 degrees. 20 degrees above the horizon. Okay, so we got a shadow. If the sun's here, here's the shadow of my statue. My statue is 12 feet tall. Find the length of the shadow. So what they're looking for, the sun is behind the statue, causing a shadow, and the sun's 20 degrees above the horizon. So what I'm looking for is this distance here, which is my shadow. In relation to 12, I have opposite and adjacent. I'm sorry, in relation to my 20-degree angle, I have opposite and adjacent. So I'm going to write a tangent function. We'll say the tangent of 20 degrees equals 12 over x, and I'm going to solve. So it's all about setting up the triangle. All the problems we do to the end, another 3 problems, is setting up the triangle. All right, from here, I'm going to multiply by x. I'm going to divide by the tangent of 20, and I'm not doing any math yet. And I'm going to plug this into the calculator or Desmos. And get my statue to be 32.970 feet. Because I'm going to round to 3 places, which makes it 970. And since I tell you 3 places, you need to put this 0. If you tell me 32.97, I'm going to mark it wrong. Rounding to 3 decimal places, you do not drop that 0. You don't drop that 0 because this tells me it's rounded. This tells me it's exact, and it's not. It's rounded. So always put that 0 at the end. All about the pictures. Don't be jealous of how great my statue looks. I mean, you can do your best and see if you can draw as well as I can. All right, this one's a little different. We got 2 situations. We have to make it work. All right, an observer in a lighthouse 350 feet above sea level observes 2 ships directly offshore. The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? All right, so here's our picture. All right, a picture like this they're going to give you. But what we're going to do is we're going to draw on it. So do the best to draw this picture. Pause it if you need to. All right, we're going to have two triangles here. All right, my first triangle is going to have a 4-degree angle of depression. And I'm going to come over here and draw that triangle. So my first one is this triangle. This distance is 350 because it's over here. All right, my second triangle has a 6.5 degree angle of depression. And I'm looking at this one now. So I have 2 triangles. My red one and my pink one. And again, this distance is 350 from the water to the top of the lighthouse. So what I need to find is that distance. That distance tells us how far the ships are apart. So I'm going to come over here and I'm going to draw these triangles again. I'm going to draw them again just so they're separate from each other. I'm going to draw them pretty much the same. We're just going to put different measurements on them. All right, so on both of these, this is 350. This one is 4 degrees. This one is 6.5 degrees. So what I need to find, this is going to be my long distance. I'll call it x. And this is going to be my shorter distance, which I'm going to call y. So going to here, from here to here is my x distance. From here to here is my y distance. And what I'm looking for, which is this, which is going to be x minus y. So I'm going to find those adjacents on both of these. And once I find those adjacents, I'm going to subtract them, and that's going to give me what I want. So I'm going to do my math for the top one. The tangent of 4 degrees equals 350 over x. My bottom one, the tangent of 6.5 degrees is going to equal 350 over y. All right, for both of them to solve. Let me start the top one first. To solve the top one, I'm going to multiply by x. And divide by the tangent of 4. And I get 5,005.233. And I'm going to remember that number, and I'm not going to get rid of it on Desmos or on my calculator. I'm going to leave it. All right. Down at the bottom, I'm going to multiply by y. Divide by the tangent of 3.5. 6.5, not 3. And I'm going to get 3,071.911. Those are my two distances. Now my math to find the distance between I'm going to say they're 1,933.323 feet apart. So for this problem, we drew two triangles. From my horizontal, that was 350 up, I drew my opposites down to the boat, and my angles was given. And I just had to plug in what I knew to make it work. But for these, we need to draw two triangles. There's other ways to draw the triangles, but you're going to have to do a little bit more work. This is the way I think is going to be the best option. And I drew the triangles to the side to get them off of the same picture. All right, navigation, and then we'll be done. An airport is 160 miles north and 85 miles east of an airplane. Is 160 miles north and 85 miles east of an airport. The pilot wants to fly directly to the airport. What bearing should be taken? All right, so I'm going to draw an airplane. Here's my wonderful airplane. All right, minor than in art in college, as you can tell. All right, so this airplane is 160 miles north and 85 miles east of our airport. I'll just draw some buildings. All right, here's our one runway. All right, so it's 85 miles east and 160 miles north. Okay, if you would have drawn it this way, 160 north, 85 east, we'd get the same picture. Okay, doesn't matter. All right, the pilot wants to fly directly to the airport. What bearing should be taken? So what we're after is I'm going to put a compass right on my airplane with north, south, east, and west. They want to go directly to the airport. They want to do this. They want to know what that bearing is. Okay. So what we're going to do is we're going to find this angle. And once I find that angle, I'm going to do this in terms of bearing. So to find theta, I have opposite and adjacent. Go to my calculator, do the inverse tangent, and get (27.979 degrees). So this angle is 27.979, but that's not a bearing. So what I'm going to say, we have two options. To find my bearing, I'm going to go south 27.979 degrees west. I had to make it a bearing. I could have also, if I wanted to, take that angle and got 62.021 degrees for this part of the angle. All right? Because if this is almost 28, this is going to be almost 60, or a little over 62. Because these two are going to add up to give me 90. I could have also said going west, rotating south, 62.021 degrees south. All right, both are going to be right. I found this angle, so I went south then west. If you drew your triangle differently and found this angle, you're going to go west then south. Both of these are the same, and both of them will work. So the idea, and I've said it a couple times already, for this section is make sure you draw the right triangle. Make sure you label the triangle correctly. Once you do that, you know the math to be able to finish it. All right, if you need any help, send me a message, contact me somehow. Your homework assignment's in WebAssignment. Have a great one.